1.5 Part 2. Solve quadratic equations. Find the discriminant to determine the number and type of solutions. Quadratic equation is an equation in the form of y equals ax squared plus bx plus c, where a, b, and c are numbers. Different methods that we have to solving quadratics are factoring, complete the square, and using the quadratic formula. Alright, so let's look at how to solve by factoring. So we're going to break it apart. Okay, now we think of like opposite of FOIL. So that f is going to come from that first value you have. So you want your first values to multiply to be 4x squared. So you have kind of two choices. They could either be 4x times x, okay, or it could be 2x and x. 2x and 2x, sorry, there we go. So I'm going to try that. It may work, it may not work, okay? So now we want it multiply to be 15. This is like our last term. So we want the last terms to multiply to be 15. So again, I'm not sure. It could be 1 and 15. It could be 3 and 5. I'm going to try 3 and 5. And then what you want to do to get that middle term is you want to check the outside and the inside. So if we check the outside, we get 10x. And the inside, we get 6x. So we want to think, is there a way I can make those two combine? So add up to be negative 4x. Yep, it'd be by making that 10 negative and that 6 positive. Now, you don't always get lucky and get it on the first try, but we did this time. All right, so we did some of that earlier this chapter. Now, we're going to take this a step further and actually solve this. Okay, so we need to set each of those factors equal to 0. So be careful with this step. A lot of people think, okay, it's just the opposite, so it'd be negative 3. But x isn't quite by itself yet. You got to divide by 2 also. So x equals negative 3 over 2. Okay, over here, plus 5 plus 5. 2x equals 5, and then divide by 2. So x equals 5 halves. So this one was not in an equation form. This one was set equal to 0. But let's say that was equal to y. So if these are my two solutions, what would that graph look like? So that's saying that these are the zeros, the solutions. 1, 2, 3, 4. There we go. So 5 halves is like 2.5, right? And negative 3 halves is like 1.5. Negative 1.5. So our points are at 2.5, negative 1.5. Okay, because that leading coefficient was a positive 4, that means our graph is going to end up going up. Okay, and then at each of these zeros, it's going to go through the x-axis. So it looks something like that. Now we could do a bunch more work to figure out where the vertex is and things, but I just wanted to point out that these are the zeros. Okay, all right, let's try another one. Example 2. So the first thing you need to do is make it equal 0, like we did on the first one. So how could I make that 2 be a 0? So we can subtract the 2. Now, we can't actually put the 2 with the 5x, because they're not like terms. All right, why don't you guys pause the video, see if you're able to factor this out, and then solve. All right, now this is a rare one where the inside value and the outside value of two different ways actually could get us this 5x. But notice we want it a positive 5x, but a negative 2. So if I did this one down here, I would need them both positive, and then that would not give me negative 2. Okay, so it can't be this second one. So it's got to be the first one. So if I want them to, the inside and outside to equal positive 5x, I've got to have my 6 be the positive and the 1 be the negative. So 3x minus 1 equals 0, x plus 2 equals 0. So x equals 1/3 and negative 2. All right, let's solve by completing the square. So if I want to complete the square, the first step you want to do is move that 13 to the other side. And then what you want to do is add b over 2 squared to both sides. Okay? So if this is our 1 was our a, negative 8 is our b, and 13 was our c. Whoops, that should be negative 13, shouldn't it? If we want to add b over 2 squared, we're going to add negative 8 over 2 squared. Okay, so I'm going to show the long way to do this, and then I'll show like a shorter way that you can do this. So the long way is just to multiply it all out. We get negative 13 plus negative 4 squared. Negative 13 plus 16. Then we can actually factor this side out because it's going to be the same factor. So multiply to be 16 would be 4 and 4. Got to both be minus. So then I can go x minus 4 squared, since there's 2 of them, and then equals 3. So to finish this up, we want to take the square root of both sides. Remember, in an equation, when you take the square root of both sides, you're going to get plus or minus. So then your final answer would be x equals, if I move the 4 over, 4 plus or minus the square root of 3. Okay, so that was the longer way to do it. Kind of the shorter way is if you know you're completing the square, what you could do at this step is not actually multiply it out, but know that x, if that's squared, and negative 4 if that's squared, and you're completing the square, it's going to become x minus 4 all squared. And I think that side was 3. Yeah. And then you're at the same spot you're at. So if you can get the hang of when you complete the square, maybe don't multiply that out, then you can calculate it that way. All right, let's look at example 4. We're going to do this one a little bit different. We want to make a equal to 1. So how would I make that 2 turn into a 1? What we could do is divide the entire equation by 2. So we get x squared minus 2x minus 3 over 2 equals 0. 0 divided by 2 is still 0. All right, our next step was to move that 3 over 2 to the other side, which we can do that by adding it. And notice when I do that, I kind of leave a space here. Up here I left a space as well. I'll highlight right there and kind of leave your space so that you're going to do that. Add something right here and add something right here. We have to do it to both sides to keep our equation balanced. All right, so what are we going to add? So we're going to add b over 2 squared. So our b is negative 2, so we're going to add negative 2 over 2 squared. So that becomes x squared minus 2x. I'm going to keep this as plus a negative 1 squared. If you would want to multiply it out, that's perfectly fine. If you want to change that one to just 1, that's fine too. Okay, because that shortcut, we're completing the square, so once we get those two numbers squared, we can rewrite it x minus 1 squared equals 3 over 2 plus 1. Okay, combine those. Remember 1, that'd be like 1 over 1, so plus 3 halves. You can say times 2 times 2, so it'd be 5 halves. Okay, and then we can take the square to both sides. Don't forget your plus or minus. Last step is to add that 1. Now, the only thing is we don't want to leave a radical in the denominator. So we need to, on this square root of 5 over square root of 2, let's break that apart real quick. Square root of 5 and square root of 2. Leave that one out there. So in order to rewrite this, we want to multiply by the square root of 2 over square root of 2. Rationalize that denominator. The reason we don't have to do it to the 1 and to the x is because we're just multiplying by 1. Square root of 2 over square root of 2 is just 1. So we get x equals plus or minus square root of 10 over 2 plus 1. Or another way to write that, we could say 1 plus or minus square root of 10 over 2. Okay. Either way is fine. All right, let's try the last method using the quadratic formula. So hopefully you still remember this from Algebra 1 and Algebra 2, but if you've forgotten it, we'll be able to review it quick. So as long as your equation is in standard form, the letter or the number in front of x squared is your a, b is the number in front of x, and c is the constant. So we can set it up. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget to, when you square negative 5, you get positive 25. So it becomes 25 plus 4 times 3 times 1, 12. So that'd be square root of 37 all over 6. Whoops. Okay, go ahead and pause your video and try number 6. All right, hopefully you're able to come up with it. The final answer should be negative 1 plus or minus I. So, good thing we reviewed imaginary numbers earlier this week or last week, because you're getting the square root of a negative. Square root of negative 4, so we have to pull out that square root of negative 1, which is just I, and then square root of 4 was 2. Finally, when you rewrite it, you can take a 2 out of everything. Okay, so you get negative 1 plus or minus I. All right, the discriminant. So the discriminant is just the part under the radical, b squared minus 4ac. So if the part under the radical is a positive, like positive 40, then there's going to be 2 real solutions. So if I look at the graph, it's going to cross twice. 1, 2. Okay, if I get it to be 0, there's only one real solution. So if I take the square root of 0, what that means is your graph is just touching the x-axis at a spot. It's not actually going through it. And finally, if I get 2 imaginary, that's when that number is a negative. So kind of what we just had. And then what would your graph look like? It's never going to cross that x-axis. Okay, 2 imaginary number solutions. And yes, they will be conjugates of each other. So maybe we'll get one of the solutions to be 2 plus I, and maybe the other solution 2 minus I. Or in our case, we just got negative 1 plus or minus I. That means negative 1 plus I and negative 1 minus I. So you have the plus and minus case. All right, so go ahead and try these 3. See if you can figure out how many solutions you have. All right, so for the first one, we got the discriminant to be 20. So there was 2 real solutions, okay, because that number was positive. Second one, our number is a negative, 2 imaginary solutions. And finally, if we got 0 for the last one, that means I have 1 real solution. Okay, we're not concerned about what the solutions are, just how many do we have. All right, your assignment 1.5 part 2, page 56. So go ahead and work on that and submit it to Canvas when you're done.